Team Viz. So till phase two, I was working on team consistency and data visualization. And currently, till phase two, we have already achieved strong performance on the LAIR data set and have already achieved the market industry standards. And now, currently, we have set the new benchmark above the industry standard. So till now, we were working on matrices like accuracy and F1 score. To go a step further, we use calibration curves, and I have researched on it and I have implemented it. So, to check how well the model predicted probabilities match actual outcomes. It works by grouping predictions into bins and comparing the average predicted probability in each bin with the actual fraction of positives. If the point uh, lie closer to the diagonal line, it means that it model's confidence is reliable. If it goes downward, this means that the model's confidence is underconfident. If it goes above the diagonal line, this means that it is overconfident. This helps us understand whether the model is overconfident or underconfident, which is important while making decisions based on predicted probabilities. Thank you.
This is Rishik. For our project, we built an advanced pipeline to detect fake news using layer dataset, and our goal was to go beyond simple keyword matching and understand the context of the text and style of deception. And initially, after phase one and phase two, with experimenting with our baseline model, we have now implemented text blob for sentiment analysis. And our hypothesis was that fake news might be more subjective and negatively charged. While we successfully extracted polarity and subjectivity features, we learned that sentiment alone isn't a silver bullet. That means liars can be calm and truth tellers, and truth tellers can be emotional. So we needed deeper linguistic features. So now we built a robust system, a multi-model feature set. First, we used TF idea of vectorization to turn the raw text into mathematical vectors, as we had done in phase 1 and phase 2. We initially used TF and IDF, right? So, more than that, a context matters more, such as the speaker and and the history of the speaker and which state he's coming and the history of them. So, we specifically used target encoding for the speaker's history and job title. This lets the model learn if specific politicians have a history of dishonesty. And coming to our latest advanced feature, we have written a stylometry engine. Uh, we used this to detect the shouting and emotional and capitalization ratios between the punctuations, such that like often fake news tries to grab attention through aggressive writing styles, yeah, such as the breaking or using more exclamatory marks than usual words actually uses, to show that it is something is going on actually, to make us believe that. So the model, so we get the intuition, right, but the model also need to have that level of context. So to get that, we implemented LDA. It is an unsupervised technique that automatically discovers hidden themes in the news. We actually can see patterns, like to detect, okay, this is fake news, but the model has to be trained, right, and we can't always use supervised technique. The model has to learn itself without any human labeling. So as you can see here, the the model successfully grouped terms into distinct topics, like economy in the topic 1, and the healthcare in the topic 4. This adds critical context to the prediction. And finally, coming to the ensemble model, the stacking classifier. For this classification, we didn't really just go with one algorithm. The stacking ensemble allows us, we use XGBoost to capture non-linear complex patterns and logistic regression for its probabilistic approach, where we get the non-linearity of the XGBoost and the linear of logistic regression. So both of them, we it is as a meta learner that learns which model to trust for each specific type of new statement. And coming to the conclusion of we come with our confusion matrix, the result is highly robust with an accuracy of roughly 75%, and which is actually around about the like matching the industry standard. And this robot multiple models to test our accuracies and F1 scores. How does it perform in that particular models?
So, in the phase 2, our goal was to build a fake statement classification system using layered dataset. So, we started with data preprocessing, where I cleaned the statements by removing special characters, converting them to lowercase, tokenizing, lemmatizing, and removing stop words. After cleaning the text, I extracted features using TF-IDF with 5000 features, which convert sentences into numerical vectors. The dataset also contains numerical information like state, party, and speaker job. I applied one hot encoding to convert those into numerical form and combine them with TF-IDF features into a final sparse matrix. After pre-processing, I trained two main models in phase 2, logistic regression and XGBoost. Right? And then evaluated them using accuracy and other classification matrix. XGBoost performed the best among the phase 2 models. In phase 3, the objective was to extend the work by adding a new model, doing more visual analysis, and comparing all the results clearly. So, what we did was first I introduced an additional model, calibrated linear SVC, which is well suited for high dimensional TF-IDF data. I trained it, generated predictions, calculated accuracy, precision, recall, F1 score, and AUC. Then I built a comparison table that included logistic regression, XGBoost, and calibrated linear SVC. The table helped summarize which model performs the best. Next, I plotted ROC curves for all the available models and which visually compared their performance. I also generated top 20 feature importance for XGBoost, which helped identify which words and categorical features contributed the most to the prediction.
Hi, for Project Clandestine AI, our mission is to break the loop of AI generated misinformation. My specific task was to upgrade our verification router, the component that decides if a claim is real or fake. Our team's baseline model achieved around 73% accuracy using standard word counts. My goal was to beat this using advanced BERT embeddings. So, uh, I tried a BERT system with random forest classifier. I used random forest classifier and the BERT sentence formations. And using this, firstly, I was able to achieve a accuracy of 20%. Uh, I was able to achieve accuracy of 20%. Because our labels had a lot of things: true, half true, barely true, false. And after categorizing those into just true or false by using this function, uh, we were able to achieve a hopping accuracy of 0.6, sorry, I mean 60% of accuracy. So, the state of art comparison, uh, I have tried then our with both the things which I tried with this with random forest. Yeah, here it is. So then I tried it with both the logistic regression and XGBoost again using the standard BERT embeddings, which gave me a score of uh, 0.53 by XGBoost and 0.57 by logistic regression. So this led to a crucial engineering conclusion. While BERT is smarter, it creates high-dimensional data that requires massive training sets. On a smaller light data set, the simpler models, TF-IDF, found a cleaner separating line that the complex models. So, which likely overfitted. So, in conclusion, more complex isn't always better. For phase 3 of clandestine AI, we only deploy BERT once. We expand our dataset size. For now, we stick to the lighter, faster baseline. Thanks.